So this is a very similar problem to the last one, except this is not a trig function. However, there's lots of symmetry involved in here again. Okay, so I can see that if I draw a line through here, through point D, there is symmetry to the right and left of that point. Okay, so we've been given the coordinate D, so I have the 0 point. Okay, so I have this point here, 0C, that's my y-intercept. I know the position D here. This x position is D, the y position is E. Here the x position is A, the y position is B, etc. Okay, and I know that this point here is F0. So looking at this graph, I can just start trying to pick out some symmetry. I know my symmetry is about the line. It's a horizontal symmetry, so I need to make sure I understand that I'm using a horizontal position of D as my middle point, and I can go this way and get symmetry. So here I'm starting at D. There's a symmetrical point at M, which is x coordinate A, and then this point here, PA, is symmetrical. So that's what I'm going to start with, my PA. Okay. Now I can start with any one of them if I want, but well, let's do it in an order here. What does it ask for? It says determine the coordinates, the 0 at PC. It says B, the point symmetrical with the y-intercept, so that point there. Okay, so this point's the y-intercept, that point B. And then the C is P point A, which is symmetrical to the vertex. Okay, so we're going to answer these terms in the terms that are given A to F. Okay, so let's start with a 0 here. So we're going to go with the 0 P point PC. So we know that they're symmetrical from the middle here to PC and from here to P point J. So what I need to know is this difference here. And the difference here as a vector is going to be F minus D. Okay, that's the vector. So if I want to go in the opposite direction, I need to do the opposite vector, or negative F minus D. Okay, so then I'm going to use this vector to go from D to that point. So to get the x coordinate, it's going to be D plus negative F minus D, and that'll get us to that x coordinate. So that's my x coordinate at that point, and then the y coordinate will be 0. Okay, that seems a little bit complicated. There might be an easier way to do this, I think. Okay, so that is definitely the correct answer. We should simplify that to 2D minus F. Okay. So we can use vectors and we can use distances to do this, but you got to make sure you understand when you're talking about a distance and how to find distance. We always find distance or displacement by subtraction, and we use that displacement and use that displacement in the other direction to get to that point. So I'm going to do something slightly different. I'm going to call this point x1, 0, and I know that this point D is the middle of F and x1. So I'm just going to do this, x1 plus F divided by 2 equals D. Then just solve for that x. I get 2D minus F. There's the same coordinate that I got in a much more complicated way. However, this is much easier because I'm just using the outside points divided by 2, add up the two outside points, divide by 2, I get the average or the middle. That middle point was D. So there's my x coordinate, 2D minus F, and the y coordinate was 0. This is using this idea of middle again, or average. Okay, and middle and average mean the same thing. Okay, and this idea of the positions versus lengths, okay, we don't have to worry about that so much here because all we're dealing with is position only. We don't have to worry about a bunch of lengths in which direction I'm going. I'm just using the positional middle, the outsides added together divided by 2 gives me the middle position. Okay, so I mean I could do that for all of these then, okay, because here I have my position here is 0. My position here is D. This position here is going to be double the D, right? And I could just write it the same. So I'm just going to do B here in red. Okay, that point there. If I want to find that point there, I'm just going to say that the middle D is equal to, and I'm going to label this point X2 and C. So we don't need to work out the C because we already know what C is. So I'm going to use that point X2 and C and do this. So X2 plus 0 divided by 2 equals the middle D. Well, that means that X is double D, which is correct. I go D here, D more, the same distance to there. So the point point B is going to have an X coordinate of 2D and a Y coordinate at C. Okay. This point, point A, which then represents the symmetrical point to the vertex, again, we can just do the same thing. I can find some vector from D to B, so B minus D, and then reverse that vector, go D minus B, add it onto D to get to that point. Okay, that would work. Again, I'm just going to do the middle. My middle D is equal to this point, and maybe I'll label this point. This is going to be X3 this time, and the Y coordinate is B. So I'm going to take X3 and add A divided by 2. It's going to give me the middle coordinate. Okay, that middle coordinate, this position is D again. And then I end up with solving, if I just want to know what this X coordinate here is, I just solve for X3. It's 2D minus A. There's my X coordinate. So the point at A is going to be 2D minus A is my X coordinate. B is my Y coordinate. Okay, because the Y coordinate is just going to match that position there. So here again, I've used this idea of middle and symmetry to solve for these. Now we could use the same distance as well, but the main idea is middle. I got to use that middle. And that middle describes symmetry of distance. Okay, if you want to use the distance and displacements. But again, the way I did it here, I did not use any displacement. I just used position. And the middle position can be found by the average of the outside positions.